Good morning, students. Today we are discussing about a new chapter, set theory. Okay. So basically, this chapter is from continued part of your number theory. Yes, and this set theory developed by George Cantor, the famous mathematician, and this theory was developed by him. Yes, after that, this set theory are using so many branches, but basically this is very important chapter to understand so many branches of the mathematics. Okay, so let us study the set theory. So let us peep into the definition. So definition, what is the definition here? A collection of well-defined objects. Okay, this is what the definition. But यहाँ पे आपको इस डेफिनेशन को अंडरस्टैंड करना है। क्या है ये डेफिनेशन? ये डेफिनेशन क्या बोल रहा है? अब यहाँ पे दो चीज तो जरूरी है, यहाँ पे कलेक्शन भी है और वेल डिफाइंड भी है। ये वेल डिफाइंड का मीनिंग क्या है? व्हाट इज द मतलब ऑफ वेल डिफाइंड? क्या बोल रहा है? यस, सो लुक एट हियर, हमने क्या कर रहे हैं, यहाँ पे कलेक्ट कर रहे हैं इसको, किसी ऑब्जेक्ट को, थिंग्स, नंबर को। Yes, so we are collecting some objects. They should be well defined. Well defined का मतलब क्या है? Yes, so we are not doing. We are collecting here. We are collecting the objects. This collecting object should not be changed. Should not be changed for person to person. Okay, the collective should not be changed for person to person. वही तो बोल रहा है well defined. ये कैसे? What is that? Yes, let us understand by an example. Yes, if I say that a set of natural numbers, less than 7. A set of natural numbers less than 7. So can it be possible to connect that all the numbers which are less than 7? Yes, definitely it is possible. How? We are connecting. We can be able to connect 1, 2, 3, 4, 5, 6. These are the natural numbers less than 7. And now here command. The collecting should not be changed for person to person. यहाँ पे क्या है, जो numbers हमने collect किए हैं, जो less than 7 है ना, ये जो एलिमेंट्स है चेंज नहीं होंगे। If I counted 1 to 6 means definitely some other person also count the numbers 1 to 6. It shouldn't be changed. Yes. Now comment another example. A set of successful persons in films. A set of successful persons in films. Okay, I will take an example. I will say that Amitabh Bachchan is the most successful person in the film industry. It is on my point of view, not on your point of view. What you say, sir, he is not the most successful person. There is another person, for example, Mithun Chakravarti. Mithun Chakravarti is the most successful person other than Amitabh Bachchan. Yes, it is on your point of view. Yes, if suppose another person came, these two are not a very successful person. There is another person, Rishi Kapoor. So look at here what happening. If I say that Amitabh Bachchan, you are not agree. You say that there is Mithun Chakravarti is there. Some another says that Rishi Kapoor is there. So means what happening? This collection at here, whatever the collecting we are, the objects, they are changing here. They are changing to person to the person. Yes, this shouldn't be happen while collecting. Okay, so that's why the definition says the collection of well-defined objects is called the set. Yes, and here first one is the collection of well-defined, because these objects should not be changed for anywhere. It shouldn't be changed from the person to the person. One means one you, two means two you. Yes, this is an element for 3 for me, then that element 3 for others also. So means here it is not changing, but here what happening, it is changing. Okay, so this is what the definition of the set. Yes, so understand this. If you are not understand, please revise the video and let us understand again. Yes, so let's move on with another topic, the simple topic of set theory, the representation of sets. How to represent the sets. So we are completed about the definition of set theory and what is meant by the well-defined object, means the collection of the well-defined objects. So now move on how to denote a set. Yes, so how we are going to denote a set and how we are going to represent a set. The both are different concepts at here. Denotion of the set and the representation of the set here. Yes, and basically the sets are going to represent. Basically the sets are going to be represented by the capital letters A, B, C, D, etc. Yes, so these are represented. So denotion of the sets here. Yes, and the elements, the objects inside the set, we are going to represent it by the small letters X, Y, Z, A, B, C, D, etc. Yes, so these are the objects inside the set and these are the denotion of the sets here. Okay, so now these objects inside the sets are called the elements. Called the elements of the set. Suppose an element A is present in the set A. An element A is present in the set A. Then symbolically I can represent this A belongs to A, and this symbol is read as belongs to this. Okay, suppose A is not belongs to A, means this A is not present in this set. So means I can write symbolically A is not belongs to set A. Okay, and this is read as not belongs to. Yes, in this way we are going to denote any set. Means by the capital letters we are going to denote the sets, and by the small letters we are denote the objects or the elements or the entries inside the set. Okay, so note on this point and let us move on how to represent the set here. How to represent set? Representation of sets. Yes, So basically we are going to represent the sets by in three methods. In three methods. And first one, the roster method. Roster method. What is meant by this roster method? So, what we know that the set is the collection of the well-defined objects. If suppose I list the elements of the set directly, in a process, so means in a process by separating them a commas, okay, and that method is known to be as the roster method or tabular method or list method. Yes. So for example, set A. So set A is what? If I write 1, 2, 3, 4, 5 up to 10. Yes. So we are listing the elements directly in a process. We are collecting the elements in a process by separating the commas. Means directly we can say that the elements what are present, which are the elements present in this set. Okay, and now for example, another Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. Yes, so these are the natural numbers less than 11 or less than or equal to be 10, and these are the days in a week. So means we can able to list out directly. So such method is called the roster method, and this is what the denotion, and these are the elements. Yes. So move on. The second one is set builder method. Yes. So set is what? The collection of the objects, and here what we are doing, we are directly collecting the objects. But here what we do, while collecting the elements, we just assign a common property, and that property is satisfied by each and every element of that set. For example, set A, there is an element x. X is a natural number. Such that, and when x is less than or equal to be 10, Only this example I written in the property. Only. If the set of collections are under some property, such method is known to be as a set builder method or rule method. Here we are using some rule. What is that rule? We are applying a condition at here for each and every element, and that elements whichever are present in this set, they are applied. Okay. Yes. And another example. X says that X is a day in a week. X is day in a week. So this set is written under some condition. What is that? X is a day in a week, whatever it is. Okay, and namely these two are what? The algebraic representation of the sets. Yes, so remember these 2 points. The one is the roster method, where we are listing the elements directly by two brushes by separating them by the commas, and the second one where we are collecting the elements by stating a common property where all the elements of this set are satisfied, but no one element which are present in the outside which not be satisfied. Okay, so remember this point. Yes. So another method is there. The third method graphical representation. The graphical representation, or we can call it as a Venn diagram. We can call it as a Venn diagram. So Venn diagram is basically a pictorial representation. Pictorial or graphical representation. Graphical representation of the set. Yes, and this Venn diagram means nothing but it consisting some closed figures. It may be a circle. Yes, it may be a square. It may be a triangle. Anything you can use that should be closed. Okay, and how to represent that all elements? We are just listing that all elements inside this closed figure only. As previously seen, for example, this is an example when x is a natural number and which is less than or equal to 10. So means these are all elements I can write. I will write right here. So 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So 10 because included because it is less than or equal to b. So that's why this 10 is also included here. Yes, so this is what the Venn diagram, and it is known to be as the graphical representation of the sets. And this method is proposed by Mr. John Venn. John Venn is a famous logician. A logician is provided this method to represent, and this will help to us to solve some practical problems directly without providing any, without making any mathematical steps. We can solve them directly. Okay, so this is what about how to represent the set and how to denote the set and what we call the set objects inside the set. The objects inside the sets are called the elements. Okay, so note down this all the points and